Hello, everyone. This is the BioHazards Unknown Hormone Project with Brandy Bernardi, Carol Calloway, and me, Tobias Gromas. Just a quick look at the control data. We can see the mean on the left-hand column and the standard deviation on the right-hand column. Same thing with the experimental data. We'll have that mean on the left and the standard deviation here on the right. And what we're showing you here is the two data sets compared to one another. And really, what we're going to break down here is the differences between them. So we took the experimental and control and we just subtracted them from one another to see what the differences would be. And the big differences we noticed were a large difference in weight. Our rats had gained a lot of weight, about 20 grams, which is over a fifth of their body weight. And then another large difference we saw was tibia growth. So we had actually seen that jump up by a third or more in terms of its growing rate. We also saw a large uptake in the thyroid output, and we also saw a large uptake in plasma-free fatty acids. There were a couple other changes, but we felt that these were the big ones that stood out. So our possible hormones here are TSH, testosterone, somatostatin, thyroxine, glucocorticoid, HCG, ACTH, estradiol, epinephrine, placebo, and growth hormone. So the hormones that we eliminated were, as you can see on this page, we eliminated somatostatin because it's meant to inhibit growth. We saw growth, so that automatically rules it out. Thyroxine was excluded since the rats were producing their own thyroid hormones. There wasn't a huge uptake. The levels stayed the same for the most part. HCG is produced during pregnancy, and our rats were not pregnant to our knowledge. We ruled out testosterone because there were no notable effects or changes in the testes. We didn't see a huge growth in the testes size. We ruled out ACTH, because the pituitary gland decreased its production and the adrenals had no significant changes. We ruled out estradiol because it's supposed to help with weight loss, not weight gain. We saw a lot of weight gain. And placebo is automatically ruled out because we did see changes in our subjects. It's not like there are no changes whatsoever. And then here is a short list of our possible hormones. We have TSH, growth hormone, and glucocorticoid. We like TSH because we saw the thyroid increase its activity by quite a lot. We liked the growth hormone because we saw weight gain. We saw tibia with increase. We also saw more stimulation of the thymus. A lot of those things were what we're leaning to out of our top three picks here. And then a glucocorticoid could also affect weight gain if a subject is put under that hormone for a long enough time.
Here are the results for our glucose tolerance test that we did. The results for the experimental levels are in blue and the control glucose levels are in red. And as you can see, the experimental rats had higher glucose levels during the test, but they were increased levels, but they were still under control. So they move up and increase to a point, and then they start going back down. So we were thinking that it was some hormone that can affect glucose by raising it, but not letting it get too much out of control. And we learned that growth hormone actually increases glucose production. So we thought that could be one of the reasons for the elevated glucose levels during the test. And we also found that glucocorticoids impair glucose uptake and they can suppress insulin secretion. So glucocorticoids could be another possible explanation for why the glucose levels were elevated during the test. We asked about the appearance and behavior of the rats to see if we could rule out any more hormones. We researched and found that long term use of steroids, including glucocorticoids, can cause aggressiveness. So we wanted to know if the rats were displaying any aggression. After we got the results, we noticed that the rats had thicker and oily skin. There was thicker hair on the females, and the rats also had enlarged heads. So we found out that growth hormone in excess can cause some dermatological findings such as skin thickening and coarsening of facial hair. And so that seems like it could be a good candidate for our hormone still. Because there was no noticeable difference in the interspecies aggression, we kind of started to rule out glucocorticoids. It just, we kept that in the back of our heads that this is a mark against the glucocorticoids, but one mark for it being growth hormone. So we asked for an RIA for TSH and blood plasma. And RIA stands for radioimmunoassay. And in an RIA test, you mix together fluid from the animal that contains the hormone you are testing for, and you add a purified hormone that has been labeled with a radioactive isotope. Then you add a small amount of antibody to the mixture, and then the two hormones will compete for binding spots on the antibodies. And once equilibrium is attained, the hormone molecules that were bound to the antibody are removed, and then you are left with some hormones that are radio labeled, and then some that aren't. And since some of the hormones are radio labeled, you can measure how much of the hormone was already present in the animal. So if you have a large amount of radioactivity left, that indicates that there was only a small amount of hormone from the test animal that was present in the mixture. And for our TSH RIA, the data is shown at the bottom of the slide there. And since the experimental data has a high amount of radioactivity within it, we can conclude that TSH isn't our unknown hormone. There were fewer non-labeled hormones to compete with the radio-labeled ones, which means that there wasn't a lot of that specific hormone in the animal to begin with, and that specific hormone being TSH. So it is unlikely that the rats were injected with TSH. The next test we did was an RIA for growth hormone in the blood plasma. And opposite to having a large amount of radioactivity is when you have a small amount of radioactivity. And that indicates that there was a large amount of hormone from the test animal present in the mixture. And again, you see our data at the bottom of the screen. You can see that the experimental data this time was actually much less than the control data. So since the radioactivity level within the growth hormone test is so low, we know that growth hormone was present at high levels within the samples taken in the experimental rats. There were more non-labeled hormones to compete for binding sites on the antibodies. And so these results indicate that growth hormone is most likely our unknown hormone. But just to be sure, we did an RIA for IGF-1 in the blood plasma as well. And IGF-1 stands for insulin-like growth factor 1. It is a hormone that manages the effects of growth hormone within the body. It is a hormone found within the blood and it works with growth hormone to promote normal growth of bones and tissues. So IGF-1 is also part of the growth hormone insulin-like growth factor 1 axis. So that's the cascade it's part of. And so growth hormone is a stimulator of IGF-1 secretion and action. So it makes sense that there was such increased levels of growth hormone in the experimental rats that were also going to have increased levels of IGF-1. So when looking at the radioactivity level within the sample, we can see that it is again much lower than the control group. And so as with the growth hormone test, this means that IGF-1 was in high concentrations in the experimental rats. So, our conclusion, we believe that our unknown hormone is growth hormone. This is consistent with the significant weight gain and increase in tibia length in our experimental rats. Growth hormone increases glucose production as well, so that is why the plasma free fatty acids were higher and why the glucose tolerance test results were higher. Growth hormone also explains the thicker oily skin and thicker hair of the rats. And finally, it was confirmed by the growth hormone IRA and the IGF-1 RIA. Thank you.